Okay, let's start with the lightning talks. And the first one is Adam Leventhal.
All right, thank you, everyone. So I work at Oxide. We were building a control plane that had a multi-serviced environment. I'm calling it multi-service, not microservice, because I don't want to like imply that anyone's service is small or anything. And we decided we would use OpenAPI as the way to communicate the API that each of these services was expressing. Folks have used OpenAPI. Okay, and I think you'll probably agree with me. It's okay, like it's fine. I think the more you get to know it, like the less you'll like it. It's like anything. So we were using OpenAPI, and we developed, we wanted to build a web framework that really was OpenAPI first. And I felt a little worried about building our own web framework in Rust. This was starting in 2020. But it worked out really well. We built this thing called Dropshot. On the left is like the code that you write. It's an endpoint. You decorate it with a macro. I have a little bit of a macro problem. I'm sorry. Decorate it with a macro, and it generates a bunch of OpenAPI. Terrific. We loved it. It was working really well for us. And we thought that we're using OpenAPI, so one of the things we'll be able to do is lean on the strength of the ecosystem, right? The strength of the ecosystem. That's why we loved OpenAPI. So we tried out this thing called OpenAPI Generator, which was supposed to be the best thing. Has anyone else tried OpenAPI Generator? Yeah, I think everyone will also agree with this. It was not okay. In particular, not okay for Rust. It was like this big ball of Java code that could ostensibly output code in like 15,000 different languages. I don't know about like most of those languages, but I would say no variant of like Rust options produced anything that was even remotely workable. Okay, so we thought, regretting some life decisions around this choice of OpenAPI. So we decided to build our own generator. So I mentioned I have a macro problem. We decided to wrap this whole thing up in a macro. We thought it'd be really neat to say your input is your OpenAPI document. You plug it into a macro, and out comes the code. And like that's what we built with this progenitor thing. It ends up outputting what effectively is like 75,000 lines of code in this one macro invocation. On one hand, that's appalling and awful. And if there's a bug somewhere in it, it just says, okay, there's an error somewhere at line 4. I don't know, somewhere in the 75,000 lines of code worth that we generated. But it also means that in this multi-service environment, in this kind of like monorepo multi-service environment, all of the clients and all of the servers are always in sync. Everything is generated from each other, and it has been a total fuel on the fire of this multi-service environment. So sure, like Dropshot and Progenitor were bets that we made that worked out really well. I was skeptical of Dropshot, much more skeptical of doing this OpenAPI SDK generation, but it worked out really well. So, which is to say, I think generating your own stuff, generating your own tools, I would advocate strongly for. If you find something that works like these tools, great. But it turned out to be a really enabling tool for the team. And macros are great. Thank you.
Thank you, Adam. Next one. Felipe Ramos da Silva.
So, hello everyone, my name is Felipe. I'm Brazilian. I work as a software engineer on Nexting and Fox, and I'm also a skydive athlete. And today I'm going to talk about Socketflow, which is a WebSocket library that I have been building the last 3 months. And basically, actually, every software developer at some point questioned how does some tool works in the background. And I have been working with WebSockets for a long time, and I always wondered how does the things work under the hood. And then I just started this library in the sense of learning how does it work in the background. And I know that we have well-established tools like Tungstenite and Tokyo Tungstenite in the market, but the goal here was to make something simple where a developer could just write a code, get the code, copy and paste, and have a WebSockets running straight away. So basically, we currently implement most of the WebSockets features that we have available. I'm currently working on compression and decompression for adding that feature as well. And basically, as we don't have too much time today, I'm going to show a quick example that we have. which is one of the functions that the library exports, which is start server, which you just need to send the port that you want to run the server. And you are going to get back a result of an event stream, which is basically a struct that implements the string trait, and where you can loop through that events, and you get events like new clients, you get events, new messages about the clients, disconnections, and even errors about this. And I'm going to run just as we can see, and going to use Postman for connecting on that. And I'm going to send a test message. We can see that we receive the response here. For the sake of simplicity, this is an echo server, so we are just receiving the message back, but it reports everything, like the disconnections and the errors and everything. And another thing that I have added to the library is every time we merge a new branch, a branch to the main, a new feature, it runs a CI/CD pipeline that basically runs Autobahn test suite, which is basically a set of tests, a group of tests that certifies that WebSockets is following the RFC, all the terms defined on the RFC. So it uploads this to an S3 bucket, all the test results, and we can see what are the tests that were executed and what is the expected behavior. And currently, as I said, we are dealing with adding compression and decompression, and probably in the future we will have the compression tests satisfied here. And one of the most important things that I wanted to ask is to have some feedback, what could be improved, for you guys to take a look into too, what could be improved in code-wise, and will be very much appreciated if you guys like it, give me a star, and also most important, feedback about the code. Thanks a lot.
Thank you, Felipe.
All right.
Thorsten Ball.
Thank you. All right. So what I want to talk to you about is something neat I learned last week. So it's called optimizing our rope with bit twiddling. If none of this makes sense to you, that's what this talk is about. My name is Thorsten. I look like this on the internet. And I work for Zed. We're building a collaborative high-performance text editor. And like 3 weeks ago, I came across this pull request by Antonio, who is also here somewhere. There he is, one of our co-founders. And I came across this, and I scrolled through it, and I noticed that, oh my God, like this, he made things actually pretty fast, like 70% faster in this 1.2 offset method. That's interesting. So I looked at the code, and I saw this, and I was like, okay, okay, that looks good. Now, I sent him, like an engineer, scientific message to approve of this, and I told him, this is pretty interesting. And he smiled, and then he explained it to me. So that this is what I'm going to do today. So taking a step back, what are we trying to do here? What did he do? We have a text editor, and we store text in it. We have to work with text. In our text editor, the text is represented as a rope. You might have heard of a rope before. In our case, it's represented as a sum tree, which is a B tree, right? We wrote a blog post about this. There's a video about it. All that matters today is that basically a rope is just this. Like, this is not a simplified example. This is exactly what it looked like. It's a tree of chunks, and a chunk is 128 bytes, okay? So that means, well, that's the background, sorry. The problem that Antonio wanted to solve was that in our code, we call this method a lot. It translates an offset into a file into a point, right? That's a common thing. You say you had offset 900, and you want to figure out on which row line and which column is it. You can imagine text editor does this thousands of times per second. If you have thousands of multi-cursors, even more so. So what this method does under the hood, this is the naive version. But basically, you have a counter, the point, you go through all of the characters. When you come across a new line, you reset the count, right? Everybody can figure out how this works. The problem is that there's a loop in there. You go through all of the characters, and the nice thing about our sum tree is that we can get to each chunk in O log n time. So if I say, give me offset 5,000 in this long file, we can use the tree to find that offset and go to this chunk. But once we're in that chunk, you still have to go through all 128 characters, right? So the solution is to use a U128. And how that looks like, and this is the production code, it's this. So what Antonio did is basically index information about the characters in that chunk inside the U128. So how does this work? And we're going to use a U8, right? Because the slides can't be this wide. And we're also going to only look at new lines. So the whole idea is this. You have a string, in this case, it's 8 bytes, right? And you use an U8 and you basically flip the bits where the new line is, right? So you index the information that's in the text. And let's take a second because this slide took me the longest. And how you create a mask like this, how do you create the bit mask at the bottom? It's also relatively simple. There's, again, a simplified version, right? We only have 8 bits. But you go through the characters, and you flip the bit where there's a new line. The funny thing is, you only have to do this once, not every time you want to translate an offset. So how do you use this? Let's walk through our example, right? So this is the code. We do this line by line. So we have our text, top left. These are, again, our same characters. We created this bit mask, right? We have 001, 001, 00. That's where our new lines are in our text. And now we want to know, at offset 5, where are we in the text? On which line and column are we? So we pass in our mask, basically, our new lines, and then we create a mask. And that mask basically says, you can ignore the max len thing, because that's not, offset is not max len, it's 5. So we create the mask that's all ones. That means up to character 5, this is what we're interested in, okay? So then we take this, and we bit and it with our new lines mask that we passed in, and then we count the ones, okay? And we come out with this. So that means up to character 5, this is how many new line characters are there in the text, okay? And if you see the count once and you think, I'm cheating, we're again counting, this is another loop, this actually compiles down to one instruction. So the CPU, they're pretty good with zeros and ones, right? So they can count ones pretty fast. So we have this, now we know on which row we are. Now we need to figure out where the new line is. So we take this again, now we count the leading zeros. Again, one CPU instruction. And then we put this down here in, 5 minus 3 is 2, and we end up with the row and the column being 1 and 2, right? That's how it works. I think you get the idea, right? We take a number, we index information about the text. So now the question is, who doesn't like micro benchmarks? And we recorded this earlier today, and I was surprised by the results. So this was the before code, right? The naive solution, you go through the text, you count all of the new lines, blah, 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 blah. This is the after, and then this is the benchmark. Again, it's like the 8 characters, it's this mask, and then we compare these two functions. And I thought this is a toy example, like nothing would come out of this. This is too small. Turns out, it is pretty fast. You go from 4 nanoseconds to 700 picoseconds, okay? Still, it's small numbers, so I know what you're thinking. Let's go crazy, okay? Instead of U8, let's use the actual U128, right? And in that benchmark too, the results are pretty sweet. Okay, one more slide. So 55 times improvement, and we're going to write a blog post about this if you're interested in this, but that was it. Thanks.
Thank you, Thorsten. Gianluca Randazzo.
So thank you, everybody. And first of all, sorry, because basically we cut out you for me, and I don't have actually not much to say and to show you all. So this is me. I'm Gianluca. I'm a backend developer. I work for Prima Assicurazioni in Italy. And I love Rust, as you can see here. All my pinned repository are in Rust, and maybe you can look here. There is also one that is kind of strange. Usually you don't see dotfiles where you have a lot of Rust in them. Usually you see, I don't know, Bash or Lua or whatever. And as a matter of fact, I have a little bit of Lua here because I use Neovim. So you can find in my config there should be a Neovim something, and here you can see all my configurations. Nothing crazy, just like the common kickstart, okay? The thing that I want to talk about now is how I basically made it up here to have 42% of Rust in my .files. And how I did it is mainly by doing silly things. And all the silly things are here. It's basically a subfolder where I have a lot of single little crates, binaries. And these are all things that I basically use every day to simplify my life. And one of them, it's not actually a binary, but it's a library. And it's called Rua here. And what this is basically a Rust module that exposes functions that then I call from Lua side. And maybe we can start looking here, would be maybe better. So diagnostic here, you can see I do, this is Lua, by the way, okay? This is just a Lua file. And what I do here is I require a Rua, and then I call some function, okay? In this case, I'm not calling a function, I'm just passing it as a value here for formatting the diagnostic. And here I filter them out. So what I did is basically rewrite some Lua functions in Rust. And I used this thing here that is called mlua. So let's go into the Rua library. Here we go. And this thing with a couple of features that I actually, maybe the serialize, I don't even use it. But yeah, maybe let's look at the code, lib Rua. And that's basically it. I'm defining a Rua module, if you want. And I put inside it a couple of functions. Okay, these are my Rust function, the format diagnostic that we saw before. And sibling to it, there is also the filter one. And here what I do is basically format the diagnostic and filter them out. The LSP diagnostic, by the way. So that's basically it. So nothing special. Again, sorry again because we cut you out. So that's it.
Thank you, Gianluca. Domenico Mastrangelo.
Thank you. Hi, everybody. I'm Domenico. I am from Italy originally. I work in Germany right now. Currently, actually, about to move to Helsinki, Finland. And I've been in tech for the last 15 years or a bit more. Currently working in DevOps. So not really programmer, but I do handle a lot of web apps, mainly written in Golang. And now I'm trying to switch to Rust. For this, I use Axum, which I'm going to show you today. It's quite easy to use, even though Rust is usually used in system programming. Using it for web development, it gives you actually a very good leverage on how many resources you have to have in the on the servers. So how many servers you have, how much you spend, and also the ecological impact of running faster. And running an Axum web server actually is pretty easy. You have to use Tokyo. This function is used to start the logger, which is defined here. It's just a subscriber builder. It will catch logs created with functions like warn. There's also info, debug, etc. And it will print them out. You can, as you see here, print them out as JSONs for easy readability if you print them, for example, in Grafana or Datadog. Following that, you just start a TCP listener, bind it, maybe not securely on every port, on every Ethernet cable. Port 8080, tracing error failed. Here we create what you can use as dependency injection. It's a vector of string. You can use it You can pass everything. You can pass DB connections, a connection to Redis, etc. And it's passed as an arc. This is because it's async and it needs to be passed through multiple threads. After this, it's just Axum serve, and you pass the listener, and you pass this call. To create a router, you create it pretty easily. You see here we create app, create router. You just get the state, set the routes here. We do route hello. We get a post request, and we get a get request. This is how you can, there's different ways, but this is how you can, in one way, return a status code OK, which is actually a 200 and a response text, and hello, getting the ID, which Axum uses something called extractors, which are a convenience way of extracting data from the request. In this case, path will return you the path and its objects, let's say. And we can go ahead and run it. I run it with trace, so you can see the logs. And you can see it started and it logged this. And if we reload here, hello world 1, 2, 3, you can modify this. It's pretty fast. Of course, if you pass a string, it's going to tell you it's not going to work. And that's it. Thank you.
This is Magnus Drangevok.
Yes, I've been currently working on some Rust code lately where I'm using this external crate that has a priority enum defined. So for simplicity's sake, I just created a cargo workspace that has 2 crates, the one with the priority and the one where I'm working. And let's pretend I don't have access to this other crate. So I quickly faced the issue of the orphan rule. So I'm just going to ask real quick, how many of you have faced the orphan rule writing Rust? Put a hand up. OK, so I guess I'm going to quickly go through what the orphan rule is. So since this type is foreign, it's in an external crate, if I'm going to implement the from trait for this type, implement for priority, we're gonna have this error saying that only traits defined in the current crate can be implemented for types defined outside of the crate. And if you look at the Rust book, when this is addressed, you will be suggested with this pattern called the new type pattern. And what that essentially is just a type that wraps this other type, like this, priority wrapper. So this type is no longer foreign. So for this, I'm allowed to implement from. And then when I use this, I can just go and use priority wrapper from some number I got from another system. It's a very nice variable name there. Yeah, and we have to implement debug for this to print it like that. Now we got no errors. Everything's fine, but the downside of this, I think, is that this type might have some associated methods on it. And when doing it like this, I either have to access it through this .0, or I have to resurface them in this wrapping type. So I was thinking, what if I could just implement this from function, but not have these drawbacks? What if we, instead of implementing the foreign type locally, we implement the trait. So what that will look like is basically, instead of using the from trait from the standard library, we're making this priority extension trait where we basically just make a very similar signature to the from trait and implement that for priority. Now we don't have this priority wrapper anymore. We we just use the type that is foreign, and we now have this function available. So first of all, now I don't have to derive debug. It's implemented in the foreign trait, so I don't have to do that locally. I also don't have to go into the wrapping type. And I also have access to all the associated methods for this foreign type. So that's basically the pros and cons, whichever you choose. I was curious is this like a new trait pattern or something like that? So I jumped into Rust Discord a weeks ago, and I was told that this is actually called extension traits. And if you were to use them, it would be nice if we name them like this, where we put the extension at the end. There's an RFC for that, I think. And the downside of doing this, I suppose, is that I just implemented this trait in the same file. But if I had moved it to a separate file, then I would have to import it in order to use this function. But the language server is really great at finding it, so you will get it suggested as a code completion, just hitting command period, something like that. So I actually favored this solution in my case over the new type pattern. So I just thought I was gonna bring it out to you people, as it's not being mentioned in the chapter about orphan rules in the book.
François Moquer.
So I'm one of the maintainers of Bevy, and as such, I often do small games with Bevy. And one of the things we often do is in games is pathfinding. So maybe a lot of people here know already the A-star algorithm. It's nice, but it doesn't produce very nice paths. It's slow, and it only works on grid. So I was wondering if there was anything better. I looked, and there's this thing called any-angle pathfinding. As you can see, unlike the A-star algorithm that will go straight between nodes, it will try to cut corners and go faster. So great. And then I said, let's look for the optimal one, because we're doing Rust. So near optimal, not good enough. Near optimal, optimal. So NIA looks good. Is there anything better? Optimal, but only on integer. Poly-NIA, generalized NIA and is optimal. Okay, let's do this one. There is a research paper that describes how it works. Nice, we're going to re-implement it. And even a referential C++ implementation. So I was wondering, okay, I'm going to take 1 week, the paper, the reference implementation, and I'm going to rewrite it from scratch in Rust, because that's what we do. So first try was going from the reference C++ implementation. It went very bad. There's a lot of pointers everywhere. I did not manage to do it. So I restarted from the paper that described everything to do, and using the implementation as to verify when I had differences. So I have it working. It's faster than the C++ implementation by 25%, something like that. And the way I did it was rewrite exactly the same output to verify that I have exactly the same result than the C++ implementation. So in 1 week, I was almost there. It took me 3 months to finish the almost part. And now I have something that works in Bevy, that works in Wasm, and yeah, I can get it working in my browser. So for example, this one, yeah, okay, not the the funniest one. We can have with many agents. This one should spawn a lot of creatures doing pathfinding, and it just works in the browser. And now I'm doing extensions to the paper to support things that were not supported by default. So for example, overpass and bridge. So in this case, the agents will decide to go over the bridge or under, depending on if there are obstacles. And yeah, I'm doing physics engine integration, stuff like that. So yeah, a lot of fun things to do with that. And the fun thing is I publish my implementation of Polyania, and then I receive message from people, for example. This is people that use my implementation in their front in JavaScript, in Wasm, to find the shortest path to the office or the exit or the emergency exit and stuff like that when they design buildings, and now they use it to design better buildings. So why not? I also received a message from someone in a marina wanted to integrate it in their software to drive boats in the marina. So yeah, my takeaways are rewriting in Rust, it's real, you should do it. Float comparison, it's horrible. I deeply regret it. Most of my bugs are from float comparison. And yeah, you should try fun things. Sometimes it's useful, it's fun, and you will never know who will use it. Thank you.
Matteo Bertini.
Thank you. So today I'm not talking about Rust, because if you found Rust, perhaps you also found another plenty variety of strange languages. At this time I'm talking about array languages. That is something a colleague of me introduced me to. Array languages are quite strange, but the idea is quite simple. They work on arrays. The basic type at the end is the array. You apply something on functions on array, and most of time work on collection of types. So, for example, when you assign a matrix assignment A to B, implicitly it maps to a double for loops that does the copy in the C word. So you have this idea of operation on arrays or arrays of arrays or stuff like that. The fun things in this kind of languages that most of them, a lot of them, instead of using a normal syntax, end up finding this kind of strange and colorful glyphs to represent the code. So, for example, if we took for Uya, that is one language of this kind, you can find a beautiful web syntax to try it. So if we comment some stuff, we can see the first line, put on the stack a list. If we remove the strange key something operator, we can see that we are implementing reduce. We can see with hovering it that this is the reduce and this is the function we are applying. If we put back this strange syntax here, this is consuming passing the argument to the function, but also putting it on the stack. So we have grown the stack. We have now 2 elements. So we can count the second element, have 4, and at the end, you can divide and have the result. And obviously, you can write a one-liner with something like Egyptian stuff, and good luck to read it again after writing once. So the winter is coming, and so Advent of Code is. So perhaps I tried it a bit, and when you, the day after, try to read it back, it's quite impossible to understand, well, what is this, what is that? And this is one kind of array languages I found. Another one is an array language for performance. The idea of the array language is that you can, most of time when working with arrays, you are thinking on operation on indexes. If you can keep the operation of the indexes abstract for the most of the time, you can at the end write down code that is very, very performant. And this is what Futark is doing, is a research language from a university in Denmark. And I found it interesting, in part because the syntax is, it's Python-like, so you can read it at least. And the second thing is that it's has a very good tooling. So for example, in this code, we are defining a function that takes some stuff, with marked is at entry, and this is something magic that when the compiler will generate a sieve wrapper, we'll have an entry point from outside. We can pass in some stuff. For example, this is the input. This is a test. These 4 lines here are a test, and these 2 lines here are random input to benchmark this code. You can embed in a few lines the main things you think are important to it. So, for example, we can run the test. The output is this is running some stuff, do a 2D stuff, and tests are running. We can run the benchmark, and everything works. We will output something very like Hyperfine in Rust, and we can also switch to another backend, for example, multi-core backend. So now the backend is switched from the linear C1 to the multi-threaded ones, and whether the first run with small data is almost unchanged, the bigger run is 6 times faster. So it's very fun, and the tooling is very good. So I think, I don't know if the cargo is involved in stuff like this, but if you have time, you want to try something fun, array languages are a good time to spend on it. So thank you.
Okay. Arthur Belleville.
Thank you. So I work at Datadog in a team called Sensitive Data Scanner, where we scan observability traces, logs, and RUM events to remove sensitive data. And so we used to have in 23 and past years a Java library that would scan our regexes, like apply our regexes to our logs and traces. And we actually decided, for various reasons that I will explain later, that we moved to Rust. So we created, we open sourced a custom regex engine that is here. It's a public repository, and that offer some various advantages, like having Go bindings, because if you use Datadog, you know that the agent is written in Go, and so in order to scan, if we want to scan events from the agent directly, we can use Go bindings to actually scan. And also from Java services, as they are in the backend of Datadog, we can also have Java bindings to the REST engines. And it also compiles to WASM for browser usages. And we actually also gain some performance while doing that. Here, the blue curve is the Hyperscan version, and the orange curve, as you might guess, is the REST engine. And so, as in a CPU usage, you can see that we divided by 2 the CPU usage, and as well here, the CPU per message scan is actually better. So yeah. That's probably it for me.